So we are still continuing with our example lying under the second experiment of determining the focal lengths of convex mirror using a plane mirror. It is not any different from the first example we did, but let's try it. Maybe if you have not been getting the first one, follow this and see what exactly happens. Here it goes. A plane mirror is placed 10 centimeters in front of a concave, in front of a convex, because we are looking at the convex. In front of a convex mirror, so that it covers a half of the mirror surface. A pin 25 centimeters in front of a plane mirror coincides with that of the pin in convex mirror. Okay? So we are dealing with the convex mirror. Find the focal length of the convex mirror. I would therefore advise that before doing anything, to solve this problem very well, let's have some simple sketch diagram. And how do we sketch it then? If we are to sketch it, I'll draw that as my principal axis, and then I can now say my convex mirror is this. Okay? They say the plane mirror is placed 10 centimeters in front of convex. Already this is my convex mirror. And now I'm going to put here my plane mirror, but they have given you the distance from the pole of the convex mirror to where the plane mirror is as 10 centimeters. Okay? And now they say it is covering half. Covering half, it means that this is a half, this is also a half of the length of the word, because this is the full length. Half of it, half of it. So we are covering half, leaving the other half up also to act. A pin 25 in front of a plane mirror. Plane mirror is here, so there is a pin somewhere here. Okay? Maybe we have our pin here at a distance of 25 centimeters, okay? At a distance of 25 centimeters in front of a plane mirror coincides with that of the pin in convex. That when we put a pin here, as you're seeing in this plane mirror and as you're seeing in this convex mirror, the two images coincide. But they coincide, when they are coinciding, this distance here, assuming it is going to be here, this is image due to the plane mirror, it should also be at 25. Because we said that in plane mirror, the object distance is the same as image distance. So if this is the object distance, the image also should be 25 behind. And they are saying that it's coinciding, that means that even this convex mirror will as well have its diminished image here. Okay? And for the convex mirror, this is acting as the V, and this is acting as the U. Okay? So if we are then to calculate, if we are then to get the focal length of this, then we should know the U, we should know the V. How then do we get the U? Okay? How do we get the U? So we shall say our U is equivalent to, from the diagram, U for the convex mirror, U, this distance U will be this plus that, which is 10 plus 25, that is 35 centimeters. And then V will be this distance here, and it will be equivalent to 25 minus 10, and then I'll remain with that. But it is a negative value because it is a virtual image. So it is 25 minus 10 to give me 15, but a negative centimeters. And then I can now come and say, using 1 out of F equaling to 1 out of U plus 1 out of V. Okay? So what is my F that I'm looking for? It is 1 out of F equal to 1 out of u, we have already agreed, it is 35, and then plus 1 out of negative 15. Clear? And then you are now supposed to think here, where are we going to get the LCM? The LCM here looks to be 70, or you can even just subtract. You can press using your calculator. If you can't get the LCM for simplification, to save time, not to waste time looking for the LCM here, because I have 70, 105. Let me see if 105 is divisible by 15. So 105 I think will work. Okay? So LCM can be here 105. What is 105? Divide by 105 divide by 35. That is it. 3. And then minus, what is 105 divided by 15? That is 7. So that means that 1 out of f equaling to negative 4 out of 105, and the f is 105 divided by negative 4, and the f equaling to 105 divided by 4, that is 26 negative 0.25 centimeter. Okay, so the focal length, therefore the focal length is 26.25 centimeters. That is the focal length for our convex mirrors. The negative, we said that it is just because we know convex mirrors have a virtual focal length, and in reality or practically this could be a length of around 25 there, because it's a multiple of 5. It should be around 25 practically, but by calculation we are just coming out with this, and I'm saying it is a negative, but we conclude using a negative positive because we know the focal length of a convex mirror is supposed to be a negative. Let's meet in the last example.